right, thanks everyone for joining. Good morning or good evening or maybe middle of the night, depending on where you're at. We've got people from all over the world. I recognize the names. So thank you so much for taking the time and attending our hands-on training webinar. For today, our goal is to walk you through hands-on how to implement a number of use cases in Cribl LogStream. To kick off the call, just a 5 to 10 minute quick refresher on the product and the use case, so that in case you're brand new and you just signed up because this sounded like a cool thing to spend your Friday morning doing, you'll at least know the product and the positioning. And then I'll hand over to my co-founder Triton, who will walk you through running this in your own environment. If you did not get my email yesterday, please check the chat for the webinar. I've sent a link there that is a link to a PDF that will walk you through the preparation instructions, which you can probably get done in the 5 to 10 minutes while I walk through these couple of slides. Our training is implemented via Docker and Docker Compose. This allows us to run a few different containers, and so you'll need Docker on your machine to get started. And we will walk you through getting all that going. So let's go ahead and get started. So let's start with our mission. Cribl is in the business of unlocking the value of all machine data, and we mean literally all. And our view on the world of machine data, logs, and observability is that you should be able to affordably process all machine data. You should not necessarily store all machine data. And so we are the world's first with a streams processing engine that helps you work with the data before it's stored, purpose-built, and focused on logs. And there's 4 key problems that we help address in the marketplace. The first is lock-in. If you have an existing ingestion pipeline full of agents from a vendor like Splunk or like Elastic, those pipelines are proprietary, and if you want that data to go anywhere else, you're kind of out of luck. And that's problem number 1 that we help address. Problem number 2 is that oftentimes this data is full. There's no audio. Let's see. Can anyone else hear me? It seems okay. Cool. All right. Thank you. Sorry about that. The second problem that we solve is around security. And so logs are full of potentially personally identifiable information and entity identifiable information. In some markets, we've helped customers where they can't even have an IP address that's not redacted. And so there's a massive problem with potentially sensitive information in logs. The third key problem that we help address is missing context. Logs oftentimes are very dumb. Metrics oftentimes are dumb. They lack the dimensionality that will help you with your troubleshooting, because they may just say, hey, this thing talked to this thing. Well, what application was that? What data center was it in? Who owns that? And oftentimes the original data is missing all of that critical dimensionality and context. And the last key problem that we help solve is around data quality. And it should be no secret to anyone on this call that logs are often full of just junk and waste. And a lot of that data is not particularly valuable to everyone. And we are a real-time observability pipeline. You'll see a post coming out next week as we're starting to expand upon this message of being an observability pipeline. So what does that mean, and what do we do? We are the first streams processing engine purpose-built for logs and machine data and observability data. And there are 4 key use cases that we find ourselves put to work in. The first is routing. So being able to take data from anywhere and put it anywhere. And so that could be translating Elastic's ingestion pipeline to put data in Splunk. That could be taking data from Splunk's forwarder, but also putting it in Honeycomb or Snowflake or S3 or Kafka or Kinesis. And so you can easily adapt and route that data to the place that may be the most cost-effective destination for you, or it may be just that you need that another team needs that data. Very frequently, we find ourselves being put into service because the data is headed to something like a Splunk, but they also want the data in their data lake, for example. The next use case is around security, so redacting that sensitive information, encrypting contents of the data, hashing sensitive information. The third use case is around enrichment, which is taking that original log data, looking it up against a service discovery system, against GeoIP, against DNS, against an asset or inventory. So being able to bring additional dimensionality to your logs by working with them before they're stored. And the fourth key use case is around transformation of data. So dropping, one of the most frequent problems that we hear about is that modern logs are JSON, and they have a ton of fields, of which not all of those fields are particularly interesting. And so you have to store them, you have to process them, and that adds a lot of expense to the overall running of an observability system. And so we can help you drop fields that you don't care about. We can help you sample and keep 1 out of every N events. We can help you aggregate and convert logs to metrics and be able to output it to a cheaper metric store. We work on events. At the time in which data comes into Cribl LogStream, everything's an event. A metric is an event. It comes in, it has a metric name and a value. A log is an event. An event may come out of a variety of different places, but it describes a point in time. So at a point in time, this set of key value pairs describes something that I want to work on. Oftentimes, especially in more brownfield installations where you have applications that are maybe 5, 10, 20 years old, there's a lot of nested data structures, JSON in JSON, Ceph inside of JSON, inside of syslog. It gets really crazy out there. And so we work on events, and we work with any structure that may come into us. And we are also a schemaless engine. We support data that comes into us in any shape. If it comes in from Splunk, it'll have fields like _raw, _time, index, host, source type. If it comes in from syslog, it'll have fields like an app name and a facility and a message. If it comes in from Elastic, it's going to have things like input and host.name instead of host, and it's going to have a field. The message is going to be in a message field. If it comes in from Kafka or Kinesis, it could have any kind of shape. And we work with data in any shape to help you adapt different schemas and different shapes of data to the shape that it needs to be in for the right destination. So Cribl LogStream, from a architecture perspective, we support all of these different sources and destinations, and we run the data through a series of routes and pipelines, which you'll become familiar with as we walk through the hands-on training over the course of the next couple of hours. And so we make it easy and possible to adapt data from a Kafka stream to send it into Snowflake. We make it easy to take data from a Splunk forwarder, but put it into Elastic as an example. And from an architecture perspective, depending on kind of the protocol, you may have kind of an load balancer here. We can deploy on VMs, we can deploy as containers, we can run in Kubernetes, we can run in Fargate or ECS. We can run pretty much anywhere you want to put us. And all of these protocols, if it's, for example, Splunk has load balancing built in. If it's more like syslog or TCP, you may want to have external load balancers. And then we generally handle delivering the data to the destination like Splunk or Snowflake or S3, etc. Deploys standalone. You can also deploy it as an app on a Splunk forwarder. Again, I mentioned we deploy in ECS, we deploy in Kubernetes. This messaging is actually old. We're now tested at multiple petabytes per day from a single management console. And then the last kind of key piece of technical information around scale out is our general guidance is about 300 to 500 gigabytes a day per core. We are a stateless processing engine. It scales linearly with the amount of processing power that you add to it. And so it essentially keep throwing more cores at it, we will process more data. General guidance is 20 to 50,000 events per second per core. And we've tested that at petabytes per day. And we can deploy that essentially anywhere that you would like to run that. And I did that in what I promised, which was right around 10 minutes. So I'm going to hand the call over to Dratan, my co-founder, and he's going to walk you through the hands-on portion of the lab. Hopefully everybody's had a chance to go get your environment set up and get Docker loaded up on your machine. And Dee's going to walk you through hands-on a couple of these use cases, and you should be able to follow along right inside of your own environment. So we're running the exact same environment that you're going to be running on your laptop. So Dee, I'm going to hand it over to you.
Thanks, Clint. Appreciate it. Thanks everybody for joining. So Clint shared earlier in the chat. So if you scroll up, a URL that has the PDF for the lab manual instructions. We also share that via email. So if you can just go right ahead and open it up. The first section of the PDF is basically setting up the environment. So for those of you that have Docker installed, these or have used Docker in the past, these instructions should look fairly familiar. For those that are new to it, my suggestion is just go get it, download it, install it, and we'll wait here for the first, let's say 5 or 10 minutes until you set up the environment. And then once you do so, we'll go through all the steps, starting with routes and pipelines, and then continue through the lab. Clint, I'm gonna take over and start sharing if you don't mind.
Yep, go ahead.
Okay. And I just need confirmation from you whether you see my screen. I'm sharing the PDF on the left-hand side here. Clint, I just need
not seeing your screen. I don't
not seeing my screen. Okay. Let's see here.
Oh, you can see it. Okay. They can see it. Just me then. Go ahead.
Okay. Okay. Cool. Right. So, get the PDF going, and then just follow this first 4 steps here to get our instructions for pulling down the containers that stand up the lab, and then in about 5 minutes or so, I'll start. If you're not able to follow with me, obviously the session here is being recorded, and we're going to share this with you. The PDF is also being shared, so you should be able to do this on your own as well. So I'm just going to pause here and go on mute for 5 minutes, and then be back at 1:20.
If anyone has any questions as well, or problems with the with getting your environment set up, then please just paste them in the chat, and we'll try to help you there as well.
All right, folks, we'll start in 2 minutes. All right, folks, we'll start with the lab now. As Clint pointed out earlier, if you have any questions, put them in the chat. Clint will be actively monitoring that, and any questions that you may have about the lab or Cribl or certain functions that we're going to go over today, be more than happy to entertain those questions for you. So, assuming you've got everything going, once you have it. Once you pull down that Git repo, all you got to do is really just do a Docker compose up here, and this should bring up the entire lab. While that comes up, so the way the lab is set up, really, it's extremely simple. So there's a data generator that is creating a semi-structured, poly-structured event, pushing them through Cribl. And then Cribl then is pushing it to a Splunk container. To log in both in Splunk and Cribl, use the admin username and then Cribl demo password for Splunk and then admin for Cribl. This should ask you, the Cribl UI should ask you to change the password on first login. Both are accessible via localhost. Cribl is on port 9000, so when you come in, you're going to have to land in a UI that looks like this, and then Splunk comes into the search app. So this is the Cribl demo. It should land in something like this. So assuming you have this going, I'm going to go ahead and get started with the first lab. So the first lab is essentially just learning your way around the Cribl UI, and we're going to talk about routes and pipelines. So when you come into Cribl, just to give you some idea of what we have here in the UI. So on the right-hand side, we show some basic statistics about the events coming in and events going out, and then generally speaking, some byte throughput and event throughput. And then on the lower right here, for the inputs and the outputs that are active, as well as for a number of well-known fields, we keep sort of track of events in and events out, bytes in and bytes out. So this is kind of like a little mini monitoring console for this Cribl instance. So you can sort of go through them real quick, and you can actually see that everything is active. Back on the left-hand side, just to go over the sources real quick. So there's a whole bunch of sources that we have here enabled. Data is coming in for this particular lab is coming in via HTTP. There's a number of ports that we're listening on right here. As Clint noted earlier, we do support another variety of data sources. There's more coming up for version 2.0. And likewise for destinations, right now, there's a number of them, more coming, but the only one active in this case is just Splunk. It's a single instance. Status is, if you click on the status here, it's active, data is flowing in. There's no problems, no errors whatsoever. Back to the home screen, so that was the right pane. The left pane is where we start building routes and pipelines. this is a tabbed interface here. So as you can see, there's a whole bunch of pipelines that we ship with. There's only one route though, and there's only one pipeline that is associated with it. For those of you who don't know, the way Cribl LogStream actually works is data comes in at the top of the routes here and then just sort of falls down through all the routes, and we're going to build a couple here. Based on the filter condition that you set, the route engine will determine what pipeline to send the data through. So in this case, all the data that is coming through matches the filter true, and it's going to the main pipeline, and the main pipeline is just basically doing, it has one function called eval. The eval function is just adding a field called Cribl, and the value is yes. So if you go to Splunk here, and we look at what's going on, say index Cribl, let's do head 10, and look at, let me just make these fields preferred fields so that we can see them here. You'll see that the value of this field is set to yes, right? So let's just start with lab number 1 here. Let's just go ahead and go to routes and then start doing the first step here. So let's go to pipelines and add a pipeline. This is a pipeline that we're going to build for the rest of the lab, and this is where we're going to add functions and a whole bunch of other things that the lab calls for. So add a pipeline. So create a pipeline. Let's call it a new pipeline. Okay. Okay, well, that exists already. Call this. Did I do this again? Oh, of course. Just exit out here. I'm going to build a new pipeline called new pipeline. There you go. Okay, and then back to routes. Let's create a new route, add a route, and call it new route. We're going to leave the filter as true, and then we're going to set the pipeline to new pipeline. So I'm going to select that here, and then we're going to leave the output as default. The default is the Splunk output that we already have configured. Save here, and then I'm going to move the new route to the top of the route stack. So what's going to happen is here slowly you're going to start seeing the events here. After I save it, the new route will start getting all the traffic as opposed to our main route. Routes are meant to consume traffic. So as the events come in, when the filter matches to true, all of those events will get sent over to the new pipeline. And you sort of start slowly start seeing the events here, the percentage drop from 100 here, and then sort of start going more at the new route. Okay, so now that we have a pipeline and a new route, let's go to the next lab section for transforming the data. I'll pause here for a second and see if you have any questions before I move to the next one.
I think we're good, D. I'm talking to a couple people, but we're
perfect. Yeah, I'm just double checking the Slack channel here, but okay. Excellent. So let's move on. So the first lab actually is the one where we're going to transform the data. So let's say we have a requirement for adding new fields to this event, and this is just to showcase really quickly how easy it is to add or enrich events or add fields to this event. So we're going to go to the new pipeline. So I'm going to click here on new pipeline, and I'm just going to add a function. So click on that function. And if you look at your UI, there's a whole bunch of functions that we ship with out of the box. There's a number of standard functions. There's formatters. There's some demo functions that we ship with the build that you guys have right now. There are some functions that we call beta functions. These are tested on some customers, but not fully vetted from us. And then there's a whole bunch of other advanced functions that we ship with. So in this case, let's just go ahead and add an eval function. So select an eval. we're going to leave the filter here to true. So we want to apply this transformation to all of the events. And looking at the manual here, I'm going to add a new field called data center. So on the left-hand side, I'm going to enter data center. And then on the right-hand side, I'm going to enter the string NYC. I'm going to save it. And all the events here will actually start getting the NYC value, right? Before, so if I go here now and look at data center, so if you look in Splunk, there's actually a field called NYC, right? And I have to do a double colon here because NYC is an index time field, so our data center is an index time field. So there you go. For those of you who are not familiar with Splunk, we do have a capture capability. So let's just go ahead and do that so that we can see transformations in real time. So I'm going to do a preview of all the data that comes in and start a capture to do that, so that when we do these transformations, we actually do it on the preview on the sample data, so we get some confidence that our transformations are supposed to work the way we want them to work. And then save them, right? So let's go to start a capture. So I'm going to click this button. So click on preview, click on start a capture, and then you can change the expression. Either leave it to true that we only have one data source coming in, but if you want it to be specific, you can say source type equals business event. And let's capture. I don't know, let's capture, well, let's leave this at a default. So 10 seconds or up to 10 events, whichever comes first. Okay. And I'm going to save this. And let's just run this capture through the new pipeline that we just built. So I'm just going to run this. And you're going to see that two fields have been added: the data center field, as we did here, specified by the eval, and then for every data point or every data event that comes through Cribl LogStream, we inject a field called Cribl_pipe, which the value of which is the pipeline that processes events. In case you want to do troubleshooting, or you sort of want to know what data processed, what pipeline processed what events, you can actually have a way to go back to it. Right. So back on the lab manual, I'm going to come in here and add a new field. Let's just say rack. All right, so I'm going to say add a rack field, and it's called value 42. So notice as I'm saving this, right, the sample of the preview mechanism that we have here will run the sample through the pipeline, ensuring us that basically the field was injected properly and the value of it is the correct one. So now if I go back to Splunk and look at rack 42, I should start seeing events. And notice that in the case of Splunk, all these events were being transformed in real time, so there's no need for props or transforms or anything like that. We just we did the stream processing of those events in real time without any restarts whatsoever. The value expression on the right-hand side here, it accepts strings and it accepts numbers, as you can see here, but it can also do some other really interesting things. So let's just say, looking at the second portion here, the data transformation section. So let's just say we wanted to add a field called host family. So since the value expressions can accept full JavaScript expressions, we have the full arsenal of capabilities here. So you can do things like, well, if host starts with, and as you notice, as I'm typing, I get look ahead help with all the functions that are available. So let's say if host starts with 127, this is called the ternary operator. Then assign, let's say, local to host family, else call it NA, and I'm going to save it. And if you notice, on the right-hand side, a new field was added. Well, I have a typo here. Well, that's a pretty good illustration, right? So if you notice, host family now here is an A, even though host starts with 127. I can immediately go back and fix my problem here. Instead of doing 127, I did 120. So I'm going to save it. And you get host family local, right? So back to Splunk, just to verify. And we look at a field called host family here is set to local, right? So it can be extremely powerful and extremely flexible, value expressions that you can assign fields with, right? What if you had a requirement, for example, that you wanted to muck around with the event payload, which is, in our case here, it's under this field called _raw, right? So let's go ahead and mask some of the fields or some of the patterns that we have here in raw, right? So I'm going to continue with this section here. I'm going to add a field called mask. I'm sorry, a function called masking function. So think of a masking function as a find and replace in steroids. Within a masking function, you can have a number of masking rules. And what's cool about this is that we have an integrated preview regex 101 looking pop-up here that allows us to build and craft this masking rules in real time, right? So let's say that we want to drop this field here called, or this pattern rather, called credits equals NA, comma, and followed by a space, right? So let's fill up the match regex section here. So do credit, and as you notice, as I'm typing, right, the highlighter engages and scans this entire input here for matches, right? And from this sample, you can select from this sample drop down, you can select multiple captures, or for if this is not an event that you're interested on, you can go into this sample, select a particular field, a particular event. So let's just say I don't like 1, I like number 2. Number 2 also has credits. Right? But they say credits equals NA, comma, followed by space. And then in the replace expression, so notice here in the output, what's going to happen if I replace it with nothing, the credits NA has disappeared, right? If I say OK here, and I say save, the preview on the right-hand side will highlight this _raw field as yellow, which means that it has been changed. And if I go in and look for credits equals, notice that there's no matches here whatsoever, right? Let's add another rule. Let's add the second one here, auto bill payment. Let me see if I can copy this. Oh, perfect. Auto bill payments equals T, comma, followed by space. And let's also nuke that all together. Save that. All right, and I save. That's also gone from here. You notice that the little animation that we had made the raw field here a little shorter. Let's add another one, but now let's make it a bit more complicated. Right? Let's do some conditional replace expressions, right? So in this case, we're looking for. Let me see. I'm going to copy this. So I have 2 matching groups here. So font type equals. And if you notice on the match information here on the right hand side, I get the matches matches values and the group numbers tightly associated. So font type is group 1 green, and then Android, which is the value of font type here, is group 2 light blue, right? And let's have an expression here that says, hey, if group 2, so if the font type is iPhone, then replace it with Apple iPhone, else leave it as is. Right, so I'm gonna go here and try to find an event that has an iPhone so that we can actually see. Oh, there you go, the exact match. So font type equals iPhone. So in the replace expression, I'm going to do a conditional now, say, hey, if group 2, so G2 and G1 are shorthands for group 1 and group 2. So think of it in set command, you have $1 and $2. We call them G1 and G2 here. So if group 2 is iPhone, right, so say, again, this is another JavaScript expression here. If it's an iPhone, then replace it with, let's say, G1 followed by, Apple $G2. Okay, else leave it as is, right? So else leave it as G1 followed by G2, right? So this is conditional replacement. So we took the value of iPhone and then just change it to Apple space iPhone, right? If I try another event, let's say event number 1 here, notice that it's not going to do any replacement. It's not going to do an addition because this condition doesn't match. This one matches, right? So I'm going to go here and just say OK. I'm going to save it, and then I'm going to go back to Splunk. Maybe it's a lot easier here to see, and look for Apple iPhone. If I can type. And sure enough, we do see some of those events coming in, right? And if I do I don't know, a better way to illustrate this is time chart count the last 60 minutes. We should start seeing, if I change it to, so there were no matches, right? Like absolutely 0 matches until we hit the change here. Okay. So let's move on to the next one. The next one is extracting new fields from payload data. For that, we do have another function called regex extract, and it works the way you would expect it to work, right? So you let's bring up another pop-up here just to get some of this validation in real time. Let's say we have a requirement to extract plan code minutes from this payload. So just go ahead and build up this regex over here. And so I'm saying, hey, go look for this pattern, plan code equals, and whatever digits follow the equal sign, put that in a new field called plan code minutes, right? So I'm gonna say okay here. Okay, and I'm gonna say save, and notice that in the envelope of the event, another field will be added called plan code minutes 1400. Nothing here, right? And obviously some down here. Right, for those of you who use Splunk, you should be able to find this extremely familiar. This is no rocket science here, no new invention. It's just extracting fields from, in our case, from the source field _row, and then just adding them to the envelope, right, of the event. And then if I go back to Splunk, just to double check, I should have plan code minutes. Looks like there's a little bug here because this certainly won't work. Plan code minutes is actually an index time field, so you need to use those double colons right there. There you go. Just go ahead and add this to the interesting some fields. But so yeah, there you go. So this was extracted in real time as data was coming in. No props, no transforms, no fields.conf, none of that nonsense. Okay. But what if we wanted to extract, to do some advanced extractions, like extract? So this particular raw event here looks like there's some structure there. So there's some space separated and some comma separated stuff here, and then there's this big array with the key equal value pairs separated by commas, right? So this is probably ripe for doing some key value extractors. So extractions where we extract both the key name and the value with one regex, right? And for that, there is a special, we've special keyed some named groups, and specifically, if I can just take this here, this regex, paste it right here. So anytime you have an underscore name underscore 0, an underscore value underscore 0, these are hard-coded values that our engine uses to say, hey, extract, you know, in this matching group, whatever you extract, assign that to be the key name, and then whatever you extract here on the value side, extract the, you know, make sure that the match here, now that goes to the value, right? So if I go in here and say save, you're going to see that all of these fields, the key value pairs that were in that raw event, in that raw field, are now extracted as you can see here with green, right? And so if I save this here, and if I run a search on the Splunk side, chances are we're going to see double of those, because we're extracting them, they're ending up as index line fields, and then Splunk is also extracting them because they are in key value, in KV formats that the auto KV is kicking in and extracting them at search time. This is just to showcase the capabilities here that whatever you can do with Splunk at search time, it's possible with Cribl at index time. So I'm going to stop here. I'm going to pause here for a second and see if you guys have any questions, or I'll give you an opportunity to catch up.
We've had some good questions in the chat, and I actually just learned that apparently Zoom has a Q&A feature, so feel free to use that too.
Okay. Very good. Yep. Okay, so I'm gonna continue with in the next page now, page 4 of the lab manual. Let's do a quick introduction on the parser function. It's an extremely powerful function that allows users to not only extract fields like we did with the regex extract, but also be very surgical in what they want to keep and what they want to remove out of the events, right? So continuing here, I'm going to add a function. Actually, the first thing I'm going to do is disable this regex extract function here, and then add a function called parser. Continuing here, I'm going to leave the function in extract mode. So when the parser function is in extract mode, what it's going to do is it's going to apply a number of parsers on the raw field here, and extract additional fields and then make them part of a bigger event, right? So in this case, I'm going to extract. I'm going to extract the parser. I'm going to use the parser here in extract mode. I'm going to change the type to key value pairs, and then I'm going to say, hey, so if I do this, say save here for the moment. So I didn't have to write this gnarly regex over here. This is useful when you don't need the parser, but we've simplified that. We just say, hey, extract all this field in key equals value pairs, and it will do the right thing here. As you can see, all these so things like order number, quote number, all of them are listed here. Now, the power here comes where you say, hey, I want you to extract, but I want you to also remove in one shot. So while the data is hot in memory, we're extracting things, and then we're also dropping things. So for example, let's just drop all the fields that start with plan, right? So I can say, hey, plan here, plan star, and I want you to pay attention to this section here. So plan code, plan description, plan name, plan price. Once I hit save here, all of those will disappear, right? There's also some additional functionality here. So we say, hey, what if we wanted to evaluate the values of some of these fields before we materialize them in the event here? Well, you can enumerate fields that you want to remove, or the additional functionality exists here where you can say, well, I want to make sure that I also don't want fields with value that have NA. So things like this, for example, JMS correlation is not available, MEID is not available, and reply to is not available. That's typically no good, or rather there's zero information there. So they just drop those as well. You can save that. And notice how that entire list of fields now it's shrunk down to the most salient sort of subset that you can make decisions further down in your Splunk analytics platform or others that you may have, right? Okay. Another interesting, so if I go back to Splunk here, you should be able to see all these fields extracted except for plan, or all the ones that don't have that value is set to NA, right? Cool. So, okay, but what if your analytics platform had capabilities to extract those fields? So things like Splunk, for example, right? In this particular case, we've thought about that as well. So we say, hey, don't extract the fields, but do sort of the same thing that you're doing, but then reserialize the event or reserialize those fields back into the row envelope, right? So in this case, we're saying, okay, go in, interpret row here as key value pairs, and then remove all the fields with plan star and all the fields that have a value of NA, right? So now notice when I say hit save here, since I changed the operation mode from extract to reserialize, all these fields will not be extracted. However, the fields that are here, these key value pairs that are here, will be extracted in memory. Fields that start with plan will be removed, and fields that have a value NA will also be removed. So if I hit save here, I notice how the raw event now got shrunk down to, so if I look at some basic stats here, the row length went from 1.08 K in 2 by 741 bytes. So that's a 32% sort of reduction in length, right? So just by doing some very basic real-time processing of the events and then making some decisions on what to keep and what to throw out, you were able to reduce the event length down to by 30-something%, right? And again, if you notice here, you still have all the fields in key equals value pair format, right? Cool. I'll pause here for a second and see if you guys have any questions before I move on to the noise reduction section. I'm going to disable this because we're going to need more noise.
All right. If any of you guys have questions, feel free to keep throwing them at me. We're answering them one by one in the chat. So
perfect.
I think we're good, D.
Yep, I'll continue. Sure. So another set of functions that I would like us to show you guys, because this is extremely useful in high volume environments, is sampling, dynamic sampling, and the suppression functions. So we'll go through them one by one. So let's just start with a simple one, the sampling. So we'll go back to add function and just add a sampling function. So what the sampling function does is the following. So given a particular filter, so given a condition that you tell it to evaluate against the data that's coming in, it will sample those events at the rate that you define here. Right? So for example, you can do things like if a count type for that, I will have to probably leave the parser. Let me go back here. I'm sorry about that. I'm going to have to go back and enable the parser function and then leave it on extract mode so that we can actually have some fields to look at. All right, so in this case, we're saying, hey, if a count type, and I'll explain this in a second, if a count type is postpaid, then sample at 2 to 1, right? So what this actually means is that the sampling function will accept all the events that come in that are given to it by the parser function. It will look at the value of the field account type, and if it matches postpaid, it will allow 1 out of 2 of those events to come in. The sampling rate, the sampling algorithm that we're using here, it's a systematic sampler, so it's not random. So it will do literally, it will allow 1 and then skip and then allow another one and so on and so forth, right? So you know very deterministically that you are allowing 1 out of 2, right? So if I hit save here, you should see that some of the events will be dropped, right? So they can look at the very first one here. Account type was postpaid, so this was dropped. Another one was allowed. This was dropped. Another one was allowed, and so on and so forth, right? So if I go to Splunk for a second and look at, we can do some statistics. So account type equals postpaid. Okay, we do get some events, and if I do a time chart, I should probably leave it for another minute or so just to see the effect of it. But you should actually start seeing this this number sort of start going down. Yeah, so it's sort of plateauing here, but the longer we leave it on, the more you're going to see this clear sort of cliff here. So where this is useful, where this is extremely useful in events with high noise, right? So it's a thing like load balancers, proxy logs and things of that nature, DNS and stuff like that, right? So if there are events that are coming in that carry very little information, then sampling makes a lot of sense. So the canonical example is if you're collecting access logs and you have a whole bunch of 200s, status codes where they indicate success, and if your common objective is to actually go in and determine what the traffic patterns are, well, you don't necessarily need to have full visibility on all of those data points. 200s carry very little information. So if you sample those at 5 to 1 or 10 to 1, you should still be able to reconstruct what the traffic was, right? And then for the other status codes, things like 500s that indicate errors or 400s that indicate client errors, you can accept those at full fidelity. So that way you don't burden your resources and you spend basically less storage and less CPU to shuffle those events around, right? I just go back here and just run the search one more time and let's see. Yeah, and it's clear now if I change it to, it's a lot clearer now. So the rate has gone down to, from 5.9 to 4 or so, right? Again, the data generator brings in events randomly, right? So it's kind of hard to get that nice and smooth, but you get the idea, right? Cool. So let's go back here. So the sampling function is extremely powerful if you know exactly what the filter condition is. However, there are cases where you may need, I'm going to disable this for a second. There are cases where you may need something more advanced. And for that, we have the dynamic sampling. The dynamic sampling is extremely cool. And that allows you to come in and then create a group key. We call it a sample group key here. And in my case, I'm saying, let's look at the account type here. So let me just explain that in a second, what that means. So let's build a group key for the account type. So unlike in the sampling function where we said, hey, account type needs to have a value or a condition that we need to evaluate has to be very specific for a sampling rate. In the dynamic sampling function, we're saying, well, go in and evaluate the value of this field across whatever values it may have. And then for each unique value, right, apply a sampling rate. And the sampling rate, make it so that it's adaptive to the the previous period volume, right? So instead of you going in and defining what the sampling rate here is, in the dynamic sampling, we give you two knobs. One is logarithmic and one is square root. So the function does the heavy lifting of saying, okay, in the previous sampling period, you know, the data was coming in and it had 1,000 events. In the next sampling period, I'm going to apply the log of 1,000, and then you know, drop however many it tells me to drop, right? So that way it's adaptive to the volume, right? And this is extremely powerful because you know, you don't have to worry necessarily about the sampling rates. It's a self-choosing sampler, and then it's adaptive based on the traffic, right? And you know, you can the way you govern those sampling periods is by clicking on the advanced settings. So let's just say here we're going to look at sample period of 10 seconds, and then 10 seconds, and then the minimum events, let's just say 5, and then we'll save this. So what this actually means is the following: for every account type, look back 10 seconds, and then use a logarithmic function based on the number of events that you get for that account type value for the next period, and then you sample it that way, right? Now, the cool thing about this, I'm going to save it here, and just so that we can see some data coming back to Splunk. But the cool thing about this is that this group key, you can keep adding stuff here, right? So we're just saying, give me the value of account type, but you can have, I don't know, account type followed by host, followed by, I don't know, source. In some cases, we've had customers use this. This is extremely powerful for looking at a combination of you know, of key values, right? So you can make this as extensive as you actually want, right? Go back here, save it, and if I come here and then look at account type. Yeah, we don't have much data here, but trust me, it is going to work, and it slowly is going to start going down here. Country account by, let's say, account type. You should start seeing. I'm going to come back and double check on this, but you should start seeing these this data sort of start going down over time. Every 10 seconds, we're going to go ahead and sample it. Right. Okay. So let's go back here and then look at the suppression. Suppression is also extremely powerful, but unlike the sampler, where it's looking at two knobs, so the log or the square root. By the way, for those that are interested, so the logarithmic sampling is, you know, is a bit more sort of lenient than the square root. Square root is a bit more aggressive. So literally you have those two options where you say, hey, I want aggressive sampling, or a little less than aggressive. So in that case, you choose logarithmic, right? Let's look at the suppression function for a second. Suppress. So the suppression function is sort of similar to the dynamic sampler, but here you get to choose the number of events to allow. So you can be very, very surgical here. So you can say, okay, for an account type, for every value of account type, I want you to allow, let's say, one event every 30 seconds, right? And then you can choose to drop those events, or you can choose to mark them as dropped, right? In our case, we probably wanted to have it completely dropped. So I'm going to sample, I'm going to disable that, I'm going to save here. And as you can see, it's already doing that on the previous side here. So this is extremely powerful also because of the key expression here. You can build the composite key, right? So you can literally define a number of fields to suppress on. We've had great success here with customers using this to deduplicate data in real time as it's coming in, right? Nothing prevents you here from saying, okay, well, look at the value of underscore raw, right? And then allow one event with a unique value of raw for every 30 seconds, right? or you can do this, maybe duplicate every 10 seconds, whatever your requirements basically are, right? Let me just go back here, account type. And if I go back here, you should start seeing how aggressively now those events actually drop. This is basically for illustration purposes, but I hope you get the idea that by being flexible enough to add as many values or as many fields here as you can, you get to achieve you get to achieve suppression that fulfills your requirements. So this is extremely flexible, as I said. All right, cool. I'll stop here for a moment, and then we'll go to masking data for redaction and basically showcasing redaction and masking. Just going to take a look at the chat window here for a second, see if there's any questions. Looks like
all good.
It's busy.
Yeah,
it's busy. It's pretty good. Okay, so let's move on to the next section, which is securing data. So masking, as I mentioned earlier, is a find and replace in steroids. So what I showed earlier was just basic replacement. Let's just see if we can mask, for the purposes of redaction and obfuscation. So we'll go back here and redact the username values. So I'm going to come here, open up the preview, and we have. I'll have to build this expression, username equals, and then let's capture that on another, so let's just say group. So what we can do here is we can say, well, I want to completely redact the username. Well, in this case, you say, okay, we want to keep group one, which is the username equals pattern, and then replace the rest of it with, I don't know, redacted, like uppercase, redacted like that, right? And you can actually see username being completely replaced here. So I'm going to say okay, say save, and if I come back to Splunk here and say redacted, already there, you can say username has been completely redacted, right? That's pretty easy, but there are, we do have other ways of masking things. So one cool thing that you achieve by doing this is that you're definitely removing sensitive information, but you're also flattening the values here. So if you want to run statistics based on the values of username, you can no longer do that because all your usernames now will be redacted, right? Another cool way to do it is by hashing, right? So let's just say in this case we want to do social. I just come here and redact the value of social with a hash instead, right? So the cool thing about hashing is that not only it obfuscates the value of the field social, but it also assigns it a unique value, right? Or whatever the collision probability is. In our case, it's way higher, way lower than the social is anyways. So the hashed value of the field social here will be unique enough for you to run statistics on it. So you sort of kill two birds with one stone here. So you redact sensitive information, but you also maintain a uniqueness in case you wanted to do statistics on it. So in this case, we're going to say, okay, so let's keep G1 so that we can maintain the structure of the event the same, so that you can extract it in Splunk. And then for G2, let's get a little fancy. So we have this global function set that starts with C. So in our case, we C.mask dot, and then as you can see here, there's a whole bunch of them. So let's just do MD5 of G2. So we're passing the value of G2 here, and out you get the MD5 of the social security number. Right? If you want it to be, obviously this is way too long, but if you want it to be a little bit more precise, you can also pass. We've overloaded the MD5 function here, so you can pass a length parameter. So you can say, hey, I don't know, keep it at 10. All right, so you scramble it, and then you just keep the first 10. So you say, okay, if I say save here, I'm going to just turn off this parser so that we can see more events here. But if I look at the social has been clearly scrambled. And if I go back here and look at social in real time, the value of the field social has been scrambled. And also the extractions work as expected, right? Just so that you guys, just so that we make sure that what we're seeing is done at index time and not at search time. I'm going to go back here to show source, get it straight from the buckets, and I look at social. Social is actually obfuscated here. There's a variety of hashing algorithms that we ship with. So MD5 is just one of them. But if you want to do some basic CRC checking, it's also CRC is available. But there's also SHA-1, SHA-256, and then random, right? So we can do that as well. So I'm going to leave it as MD5. Okay. So before I move on to lookups, I'll pause here for a second and see if you guys have any questions. Okay. Perfect. So with LogStream, we also have the ability to enrich data as it comes in using lookup tables, and it's one of the sort of enrichment of data, as Clint mentioned earlier. It's one of our key differentiators for a lot of solutions out there. We have a lot of customers using lookup tables in the millions of rows to enrich or check the data as it comes in and then make decisions based on those. I'm just going to walk you through a very simple lookup example. I'm going to go back and turn on the parser here so that I can have, I think we'll need state. Yep, we will need one of these states here. Yeah, market state. We're going to need market state. And so, so in the PDF, there's a list of US states and their abbreviations. So once you go ahead and copy that, and then go to knowledge lookups, and then just add, say, add a new state, or rather add a new file. Oops, I'm sorry. What I meant to do is create one with the text editor, right? Let's see. Give me 1 second. Let me see if I can grab these values from here. Okay. I have them on my local drive here. So we're building this lookup table. Copy, paste here. I'm going to assign it the file name. So when we create a lookup table, the first row naturally is a header, and then everything that follows is the content, right? So in this case, I have state, comma, abbreviation, or ABBR, and then just 2 columns, right? The state and its corresponding abbreviation. So, and I'm going to call this, just so that we're following the lab, US_states.csv. The editor is pretty interesting. So I could have uploaded. I don't have it saved here on my local machine, but I could have uploaded it, or you could have just built it, manually. But you can edit it via several modes. You can go to table mode here, and you can just say, hey, I don't know, let's look at Arkansas, and let's call this, I don't know, R or ARG. I say, why Arkansas? Well, because it's one of the states there. So I'm going to save it. Now let's go back to our route and pipeline. Click back on the pipeline. I'm just going to add a function. Oops, sorry about that. Oops.
And that'll be there in perpetuity.
Yeah, I know. it's only the well, I'll change it right now. Good catch. Okay, so let's go back here and I'm actually going to bring up the sample that we captured earlier so we can work with it. Okay, going to add a lookup function, standard lookup, and it's actually pretty simple. So in the lookup path, we select the file that we uploaded, so usstates.csv. We leave everything by default, so we want exact matches. The match type to be the first one. So there's a variety of those here. You can do exact matches, CIDR matches, or regex matches. And then the match type, you can do either first, most specific, or all of them, right? In our case, we don't necessarily care. We just want just exact match, right? For lookups, there are two operations here, or rather two options that we can choose. One is we can add the looked up field as a field in the envelope of the event here, or we can add it as a key value pair, sort of appended to the raw event here, which is, we built this feature mostly for Splunk because key value pairs are extracted automatically. But let's just take a look and see how both of them will actually do it. So what we're going to do is the lookup field in the event, as we said earlier, is market state. So we're going to take market state here, and then the corresponding field in the lookup is the abbreviated column, right? And then the output field, we're going to output state from the lookup, and then in the event, we're going to call it uppercase state here. So I'm going to say save. And then if you notice at the very end here, a new field was inserted. So MN, so based on this, we added Minnesota, right? So actually, if I go back to Splunk here, I should start seeing a field called state. And there you go. There you go. So state is added to all the events with matches, right? So again, in real time. And now the cool thing about this is that you can have other functions below the lookup function here, then on which you can make decisions based on the value of the looked up fields, right? So this is inserting or enriching the event with additional fields on the outside. You can insert that in the raw event too, if you'd like, in the raw field, if you like. So you can say save, and if you look over here, state equals Minnesota was actually added, so comma of that, right? So if I go to Splunk here and rerun the search, all of them will have state appended to raw, right? Sort of the same thing, but it all depends what the end system is, right? In case of Splunk, either way you do it, it's perfect. With lookups or looked up fields being part of the index time fields, it's actually pretty interesting because you can run t-stats on them and you can get some really, really fast responsive queries and searches. So I'm going to say save here and then pause for a moment before we go to real-time aggregations, and that is our last lab. Any questions? There's one Q&A. Let's see how this actually works.
Oh yeah, go ahead. Have fun.
I just wanted to say, Clint, I mean, if you want to address that, let's go for it.
Yeah, well.
I wonder if this Q&A threads will be available after the
Yeah, I don't know.
recordings.
I haven't tried before. Well, we'll hope so.
Interesting. Perfect. Okay. All right. So let's continue then with with real-time statistics and aggregations. So masking, sensitive information or securing data in flight is one of our key value props. Enriching is also one that has won us a lot of customers, and customers find it extremely useful. One of the questions that just came up was when whether we can enrich events with threat intel. The answer is hell yeah. There are a lot of customers that are using us exactly for that, to make determinations based on that information. Another very interesting one is doing real-time aggregations of data as it comes in, especially if you have metrics data or data that is extremely voluminous or extremely noisy. So we talked about sampling and dynamic sampling, suppression, but real-time aggregations are also another way of reducing the volume that comes in down to very specific time windows, and then creating statistics on those. Right. So I'll go ahead and run a couple of aggregation functions here, and we'll see how it goes, and then we'll continue with more questions. So for that purpose, I will add a function here called aggregation function. And then the way aggregation function works, now remember, we are a real-time stream processing platform. There is no index structure. There's nothing like that, like Splunk or Elasticsearch. So the only way that we can provide right now is windowed statistics, right? So Windows-based statistics. So every time that we do in terms of aggregations are based on a time window. So think of it as a tumbling window statistics here. Right, so for that, the aggregation function supports or has the capability to support multiple aggregation statements in one function, and then across multiple group by fields. Right. So in this case, let's say that we have a requirement to produce the average plan price. So plan price, we don't have it here because we removed it from the parser here. So everything that started with plan, I'm going to remove plan star from fields to remove so that plan becomes available. Let me just delete this for a second. Okay, so we have plan type here, or other plan price right here. And let's just do an aggregation function again. So I'm gonna come here and say, hey, and as you can see, as you start typing, right, you get help. Look ahead here. We include a number. There's obviously about 20 or so aggregation functions, starting with simple things like averages, counts, all the way to sum of squares and variance and all that. Right. So one thing that we can do here is to say, okay, well, take all these data and then produce an aggregation, and then give me the average of plan price here. And then we're going to group by market zip. Let's see what happens here. And I'm just going to come back here and just remove show drop events. And voila, so there you go. We have a nice looking structured output, taking basically a number of events here, extracting the fields, and then producing summary statistics of average plan price by market zip. So one way to look at this is probably a table view is probably better. If I can make it a little bit bigger here. But yeah, so every 10 seconds, we're going to do a group by of average plan price by market zip. Right? So for each market zip, we're producing the plan price, right? So if I go to Splunk here for a second, let's see what these events look like. Let's see the output settings. Let's see. Okay, that was every 10 seconds. Let me see. 1 second, what happened here? I have a field here called foo bar. Come back here for a second.
Aggregate, if you need to group by index, host, source type as well, because you're not.
We're not outputting those. So, okay.
Yeah.
Maybe can just source.
Yeah. Source type, index. And
Yep. Index. Yep. Just double check here. Okay.
I'll give it a few seconds and it should start coming in.
Yep. Yeah, there you go. Yeah, thanks. Yeah, apparently we need those extra fields here. But yeah, as you can see, we're able to take this raw data, do the extractions, and then produce for every 10 seconds, produce statistics based on based on this function. So we took the average plan price and we grouped it by market zip, right? We would have to insert, and actually I wonder if I could just insert those here, source type and index, but instead of grouping by. But yeah, so there you go. So you come up with a whole bunch of bytes, and then it's now sort of structured into some basic real-time aggregations, right? Now, the aggregation function also supports for even more advanced statements than that. So let's just say we want to do average plan price. And then we can chain statements here. You say average plan price where phone type, let's say phone type is not, let's say equals to iPhone. And then let's call this as, let's call this plan price average. Actually, what I meant to do is equals iPhone average iPhone. And save this, right? And now we should be able to get. I should just run this real quick here. 2 statistics, so we should see. Start seeing those here. Okay. All right, and if I go back here, I have to give it a minute or so because we need font type to be equals iPhone. Let me just add another one here. Let me see if I can copy off of this here. Average plan price, font type not iPhone. Okay, that looks a little better. Okay, save. Yeah, the reason we're seeing it here is that none of these captures that we have included font type iPhone. But yeah, so we should start seeing it as that, right? And if I go back here and wait a minute or so, we should start seeing events with these 3 aggregations come in. Or actually 2 aggregations. So one will be the plan price, and then depending on the phone type, whether it's iPhone or not iPhone, we should start seeing those. Well, maybe this is throwing us off. The masking function. Yeah, there you go. The masking function is throwing us off. Remember, earlier we changed the phone type from iPhone to Apple iPhone, so that was throwing us off. But now, back here in Splunk, we should start seeing, give it 10 seconds. We should start seeing the 3 fields. So plan price average for iPhone, and plan price average for not iPhone appear as part of the event here. Just like we have over here. All right, cool. So with that, I'll stop here and see if you guys have any questions. There's still another about half hour-ish left on the phone on the conference call here. So whatever questions you guys may have, just shoot them over for us in the chat or in the Q&A window. Clint, I'm not sure if there's a way to unmute.
Yeah, I can. So if anybody wants to ask so for example, so one of the questions here, and I'll just go ahead and answer it live.
Sure.
Is can we do dynamic lookups? For example, can we reach out to another system and go query that and bring that back? And the answer is yes, but be very careful. If you look inside in the same GitHub repo or same GitHub organization where we gave you the link to the training, right? There's also another repo there called Cribl Demo. If you look inside of Cribl Demo, there's a pipeline called Enrich, where we've built a couple custom functions there that will reach out to Redis and reach out to REST. To do some lookups there. Those are kind of proof of concept functions. Eventually we will ship some first class, Redis lookup and REST lookup type functions.
We have them here, Clint, if you also in the training section. In the training,
we do. Yeah. Okay.
Yeah.
Right. Yeah. Okay. You're right. So the reason why I say beware is because, for something like Redis, for example, it's designed to process, potentially thousands of events per second. Doing a REST lookup, for example, and going and making an API query, the number of log events that are likely moving through, you have a really strong chance of doing a denial of service attack against whatever API you're actually looking up against. So just yes, the answer is yes, but the reason why we have not shipped those things yet is that's part of the circuit breakers and things like that are part of the facilities that we need to build into these, so that you don't accidentally destroy whatever system you're looking up against.
Yep.
So another question is there a possibility to see all the configs in Cribl, export them or import them? Do you want to cover that?
Yeah, absolutely. So I was just looking at that. Yes, it is totally possible. So adding pipelines, see if I can just save here. Adding pipelines can be done either manually as I did, or you can import from a file, or you can import from a URL. Every pipeline, including the one we just built from the UI, can be viewed as structured as JSON over here. So you can literally copy paste, so you can import and export files. We'll do the validation for you in real time, or we persist them as YAML files in the file system, so you can shuffle them around that way too. All the configs, if you want to have a sort of an aggregated view of all the configs, we have a diagnostics page. So if you go to settings and diagnostics here, where you can see all the system info, all the pipelines that we've built, all the routes, all the inputs, and all the outputs as well. Right? With the new version that's coming up soon, we're going to have a fully sort of integrated configuration management system in which you're going to have full versioned config management, so you can configure the system with all the backend functionality that you need. So like whether it's YAML, JSON, you name it, all of them will be there, and version control too.
Cool. So a couple of other questions. Yep. There's, will there be routes and pipeline synchronization between different Cribl instances in version 2? Yes, that is the key feature of version 2, which will be out here. Well, we have a pretty hard deadline of about 17 days from now. It will be out the first day of Splunk's users conference. Version 2.0 has a centralized management console that's designed to manage multiple groups of configurations so that you can have a set, potentially multiple sites or locations or different groups of worker nodes doing different processing, all from one centralized console. That's also integrated with version control, so you can see detailed diffs of what's being pushed out and deployed out to the various worker nodes. You can also push that up to your Git repository so that you've got the configurations backed up in some sort of kind of external Git repository. So super, super cool. I cannot wait to get it out to all of you. Just playing around with it myself makes me very giddy because it's very much, it's exactly what I would want.
Right.
It's so cool. Just looking forward to rolling that out. So let's go, that one was live. And so that factors into, can Cribl generate an alert or shoot an email based off an event pattern match? I'm going to say no. You can kind of, if you want to write your own function,
right.
You can do that today. It really needs to be a first-class thing. So the hard part about implementing something like alerting is, we don't know what node the events are going to come in. So we need an ability to centralize the state of what is an alert, right? Like, how do I process conditions? How do I, we need some reduction steps in there. We need potentially a shuffle step in there. The foundation for that is version 2.0, which is now we have a central manager concept that will roll out in version 2. So features like alerting, where we need to be able to make a centralized decision based off of what all of our worker nodes are seeing, now become possible. Not coming in 2.0, but in the 2.0 line, as we get into 2.1, 2.2, 2.3,
yep.
You'll start to see these features like alerting start to emerge let's say within the next 12 months. I'll feel comfortable saying that we'll have something like that. And by this time next year, you will have something like alerting. So another question. So sending SEM fields to Splunk gives a more solid DM index, aka smart summarization. Yes, although I'm going to give you a caveat that has nothing to do with us, that has everything to do with Splunk. Ingesting high cardinality index time fields through Splunk it has a massive potential performance challenges. Due to a bug in Splunk and how Splunk's ingestion pipeline works today. So be cautious. So yes, you can parse and create all these index time fields, but be aware that you may hit significant ingestion performance problems with Splunk with high cardinality index time fields. Let's see,
yep.
One more question. Can you send reserialized data from one stream to one destination and aggregate statistics? Absolutely.
Yep.
So I don't know if we didn't really cover a lot about routes, but Dee, maybe you can just kind of click around and show final and that sort of stuff.
Sure. That's actually a great question. So what we have set up here is essentially just a one destination environment. So only Splunk, a single instance, the one that runs locally, is available. In a more sort of realistic, and all of our production deployments, typically they have more than a few destinations, right? And so the way routing works, it's actually very simple. So as data comes in at the top of the routes, we match against this filter, and then the filter indicates, or rather the mapping here indicates what pipeline to go to. The mapping is also final in the sense that for every event that matches the filter, it will go through the pipeline, and they will not be evaluated further down, right? When the final flag is set to no, what's going to happen is a copy of the event will go to this pipeline and to that destination, and then the rest, the original, if you will continue down to the next route, and then this next route now can have another destination that can take the same data too, right? So, for example, we do have deployments today where, for archival purposes, they need the data to be in S3. untouched, unmolested for 7+ years, and then a copy that is redacted, masked, reduced, and sampled to go to Splunk. And the way you do that, it's just like what I said. So you put S3 at the very top here, and it goes there, untouched, and then down here, reduced, sampled to Splunk. So that's one way to do it. The other way to do it is we have this notion of an output router as a meta destination, right? So what I showed here with making that routing decision, this is making the routing decision beforehand, but you can also make the routing decision after the processing has taken place, right? So the way you do it is you build an output router definition here. So you add, you add these filter expressions, and then you associate them with outputs, and then you make this cloning happen at the back end, say in the output side, right? Same principle. It's just delaying the routing decision. Either for some cases it makes sense to delay the routing decision. For some others it doesn't. But yeah, so that's how we do it. And then to answer that specific question, so the way we would do that, we would make the routing decision afterwards, where we would have a filter expression where we say, hey, if it's aggregated and it matches a certain condition, then you go to destination A, and if it's not, then you can just continue down the path to another other destination. Okay.
All right, so checking just one last time for any additional questions. If anybody has a question, if they want, we can also do it verbally. So if you raise your hand in the UI, we can give you a chance to talk and ask a question, or you can type them into the Q&A box if anybody's got anything else that they would like us to answer. Looking like no, so I'll go ahead and start the wrap up, and if we get anything last minute, then we'll go into it.
Sure.
So thanks, Dee, for that. I mean, a ton of content. I hope everybody had a chance to follow along. If not, we will be making a recording of this webinar available to all the attendees, and actually the copy of this webinar will go up on our website as well. So if you haven't checked out our website recently, if you go to cribl.io, there's a learn section at the top of the website where we're putting all of this type of content. I said it in the email yesterday, but I'll continue to reiterate that we believe fundamentally that product education should be free. If you're gracious enough to come to us and spend some money with us to help you solve a problem, we're not going to double dip and then try to charge you to learn how to do it. So, for the most part, other than covering our costs, if we ever do any sort of in-person education, we believe all this should just be out there in the open, and you should be able to get it. And so we're trying to make this all as open and as transparent as possible. If you are not in our Slack Cribl community, go to cribl.io/community. There's also links all over the website to the community. There's an inviter there that will send you an invite to our community Slack, where us and several hundred of our users and partners and employees are congregate to ask questions and answer questions. Come share your favorite memes with us. We love to chat with you. And any questions that you've got, you can get a hold of us in real time there. If you are a customer or a prospect that needs some additional help, we can create you a private channel there where you can feel free to chat with us one-on-one, in a more private setting. So any configurations you want to share, it's just a great way to collaborate and work together. So yeah, so I don't see any other questions. I thank everyone for coming. We're super appreciative. I hope you guys got a chance to learn some stuff. If you have any feedback on the product, please feel free to get a hold of Dee or I. We'd love to hear from all of our users about things that they may want us to do better. And with that, I think we'll go ahead and wrap it up. Thanks everyone for attending.
Yep. Thank you, folks.